In this video, we will be solving this particular problem right here. So we have a boiler that heats water for steam. 80% of the heat produced by the boiler is used to create a saturated steam at 7 bars absolute from liquid water at 30 degrees Celsius. If 165 meter cubed per hour of steam is needed, what rate of heat does the boiler output? And this is some information that we would typically get at a reference table. And so let's get started. So we have an open system energy balance. So delta H plus delta EK plus delta EP is equal to Q dot minus WS. So this delta H is the difference in enthalpy rate in and output of the system. This is the difference in enthalpy rate. This is kinetic energy, potential energy, heat transferred in the system, and energy transferred to do shaft work. So potential energy and kinetic energy will be negligible because the elevation of the material and the change in velocity is essentially zero. We have no moving parts like a turbine, so shaft work is zero also. So now we have delta H is equal to Q. A few things to consider is that the volumetric flow rate is equal to the specific volume times the mass flow rate. Also, the change in H is equal to the mass flow rate times the specific enthalpy. Combining these two pieces of information, we could get that delta H is equal to the volumetric flow rate times delta H specific divided by volumetric specific. Essentially, we rearrange this by saying that the mass flow rate is equal to the volumetric flow rate divided by the specific volume. From there, we replace this M with V, this V right here, divided by the specific volume. And that's how we got this equation right here. And now let's replace these numbers with the numbers that we were given. So we will say that Q is equal to delta H, which is equal to the volumetric flow rate was 165 meters cubed per hour, 165 meters cubed per hour times delta specific enthalpy, which was, so we have just water here and then steam. Our output is going to be steam. So we will take the number from the output, which is 2762 minus the input one, which was this. So minus 125.7. The unit was kilojoules per kilogram. Now we will divide by the specific volume. We only have one, which was for steam at 0.273 meters cubed per kilogram. So our answer would be 1.593 times 10 raised to 6 kilojoules per hour. Now we're not done yet because here it says 80% of the heat produced by the boiler is used to make steam. That means we're wasting heat essentially because 80% of what we have goes to make steam. The other 20% is a loss. So we want to know what rate of heat does the boiler output. But first we want to convert this into kilojoules per second. So we know that 1.593 times 10 to the 6 kilojoules per hour is what we have. And we know that 1 hour is 3,600 seconds. And so we would get 442.6 kilojoules per second. And kilojoules per second is equal to kilowatts. So 442.6 kilowatts. Now back to the 80%. So 80% of the heat produced by the boiler went to make saturated steam, not 100%. But we want to know what rate of heat does the boiler output. And to get the total, we say 442.6 kilowatts times 100% divided by 80%. And this makes sense because our number will be bigger because we're considering the waste. And this will equal, so we would get 553.3 kilowatts. And this right here is the final answer. And that's all we need to do.